Before starting the class, I was talking to some people here that oscillations and waves are easy scoring chapters not only in school but also in competitive examination. But even then, being simple, easy and scoring chapters, every year people are losing marks in that. Most of you are not having boards in 11th, so you don't bother about 11th. That is the reality. Most of you don't bother much about 11th. Somehow pass and go to 12th. But you don't know that in 12th one chapter is there, wave optics, where it will be telling that as you learnt in waves in 11th, there you will have struggle. Second struggle will be if you are writing NEET or JEE, then scoring chapters. 2 chapters, if you are writing NEET, expect 3 to 4 questions. It means how much? Almost 12 to 16 marks. If you are writing JEE, 1 or 2 questions, 4 to 8 marks. You know what is the meaning of 4 marks in JEE, right? Almost 20,000 rank can go up and down. Depends where you are, in which mark category you are. Same way in NEET, 12 marks, 16 marks and all can make you to get some government seat and get some private seat. That much difference is there. 12 marks can make you enter into some government college, and because of not having 12 marks, you can go to some private college if you qualify and with high good marks. So that is the importance of each marks. Thousands of ranks will go up and down in each 4 mark. So understand the importance of this chapter. Again I am repeating, it is a simple chapter. Given that, yes Yuvan, something you are saying? Which Yuvan is this? Is Yuvan Shankar?
Yes, sir.
Okay, I thought Yuvan of 12th has joined. Fine. So guys, I hope you get my point. This chapter is simple, but you have to be like continuously understanding it. If you miss one day, no, it will be like looking like what is being taught. It will be difficult to understand. So please make sure that you are not missing classes frequently and you are attending all the sessions. Come fast, Pratyunjay. Yeah. So those who are not there in previous class, and if you have even not seen the video of the previous class, you are going to have a tough time today, because I said you, it is something which is continuous. Today's class, the first page itself, what I am showing to you can frighten you if you are not there in the previous class. Anybody is there like that? Absent in the last class? You are not there. Very good. What is written you are understanding? Anybody else in the online who was not there in the last class? Anybody is there? You are also not there, no? Very good. You are also not there. Then you will have a tough time today. Maybe if you have seen the video properly, pausing, taking notes and all, then you will have some understanding. If that also you have not done, simply came for the class, then you are going to have tough time today. And those who were there, have taken notes properly, listened the class well, seen the video and taken the notes properly, for them it will be easy going in understanding class. So it depends upon how much prepared you are for this class, will decide whether you will understand today's class or not. Anyhow, coming back. So we were learning in the previous class about the equation, these things we have learned in the previous class. I am just again recalling it. First, I would like to recall you what is a wave. I said you wave is a pattern in which energy propagates. Wave never makes the particle to go along with it. Wave only makes the particle to oscillate in its mean position. So what is a wave? Wave is energy. Actually not energy. It's a pattern in which energy is transferred from one place to another place. And when the energy is being transferred from one place to another place, then the particle undergoes displacement about its mean position. I have talked to you about that. And I said to you, equation of wave, this also we saw how it came. Equation of wave is given by a sine omega t minus kx plus phi. In that each term if I tell, I have told you what is the meaning of y. Y is the displacement of that particle. See, if you recall the previous class, you can remember that if there is a wave coming, like this, and there is a particle here, and the wave hits the particle, then what is the displacement of this particle? That is only called as y. What is y? Y is the displacement of the particle which is hit by the wave. What is A? A is the amplitude of the wave. If the wave is coming, it will have some amplitude, maximum displacement, that is called as amplitude. So A is amplitude. What is omega? Omega is the angular frequency or angular velocity, which is equal to 2 pi by t or 2 pi nu. What is t? Instantaneous time. There is a difference between small t and capital T. Many are thinking both are same. It's not like that. Capital T is called as time period. What is time period? Time taken to complete one oscillation or time taken to complete one vibration. And what is small t? Small t is instantaneous time. That is for a particular time. That is called as small t. Instantaneous is a particular time. What is K? K is called as, anybody? What is K? What constant? I told. What, Anshul?
Spring constant, sir.
Spring, very good. Which chapter you are studying, man? That is F is equal to Kx, not that's
Wave number?
wave, angular wave number, or also called as propagation constant. Please guys, I am repeating, don't attend the class without revising the previous class. It will become difficult for you to understand. Propagation constant is also called as angular wave number. It is given by 2 pi by lambda. You remember this? I have taught to you. Check your notes. If you are there in the class, you will have this in your notebook.
Yes, sir.
Yes. X is the displacement of the wave, not displacement, distance travelled by the wave. X is distance travelled by the wave. How much distance a wave is travelling? That is called as what? That is called as X. From here to here, if it travels, this is X. How much distance the wave has travelled? That is called as X. And what is phi? Phi is the initial phase. If it will be 0, if the wave starts from origin. But if it is not starting from origin, it can have some value, 90 degree, 180 degree, 270 degree, it can be anything. So, it depends totally about how the wave is starting. If the wave starts from origin, then the value of phi will be 0. Even I will not repeat again to on your camera, I will ask them to put you in waiting room, okay. Your video, here and there you are offing. I am saying you one, last warning I am giving. Coming back. So, this is the representation of a wave moving in positive x direction. So, when a wave is moving in the positive x direction, then its equation is y is equal to a sine omega t minus kx. I am assuming from origin. If a wave is moving in the negative x direction, that is it goes in this direction, then the equation will become y is equal to a sine omega t plus kx. Is it clear to you? Y is equal to a sine omega t minus kx of which direction? Positive x direction. Y is equal to a sine omega t plus kx for which direction? Negative x direction. So, if a wave is moving from x is equal to 9 to x is equal to 1, equation will be y is equal to a sine omega t plus kx. If the wave is moving from x is equal to 1 to x is equal to 11, then the equation will be y is equal to a sine kx minus omega t. I hope it is clear to you. So, the wave equation is purely governed by whether it is moving towards positive x or positive y. We are talking only about x direction movement of waves. If you may ask, sir, what about positive y or negative y? Then it will become x is equal to, isn't it? That will change. Anyhow, this is the other form in which the wave can be represented. How this form has come, I told you. Put the value of omega as 2 pi by t. Put the value of k as 2 pi by lambda. Take 2 pi outside. You will get here t by t, x by lambda, and here since there is no 2 pi term, it will come in denominator. This is the equation of displacement in terms of small t, capital T, x, lambda and phi. So, any of the equation may be required for solving a numerical. See, this is the mother equation, right? This is for negative x direction, that is positive x direction. This is for negative x direction. These things we have seen in the previous class itself. If you were there in the previous class, I hope you remember all these things. Can I proceed further? Can I proceed further? Please permit me. If yes, 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 yes. So, then we have talked about this question also we solved, remember? We solved this question also, where asked you to find frequency, wavelength, speed, all these things. And then we talked about even principle of superposition in the previous class. Check your notes. I have talked about this. It means if there are two waves going and intersecting with each other, or I can say like there is a particle. For example, if I write here, there is a particle here, right? One wave comes and hits this. Its displacement will be purely governed by the amplitude of the wave. Am I right? If the amplitude of the wave is 5 centimeter, then this particle can go from -5 to +5. I hope you are understanding this. If a wave of amplitude 5 centimeter hits a particle, that particle can oscillate from which to which range? +5 to -5, isn't it? Because if it is having a of 5, it means what? It can go 1, 2, 3, 4, 5 or -1, -2, -3, -4, -5. Can it have a displacement of 6 centimeter? No. Can it have minus 11 centimeter? No. It can only oscillate from where to where? Plus 5 to minus 5. But what happens if another wave comes and hits it? Or third wave comes, hit it. Fourth wave comes, hit it. In that case, we have to do a vector addition of all these displacements to get the net displacement of the particle. This wave can displace, this wave can displace, this wave can displace. Don't just add all the displacement. It's not like displacement by 1 plus 2 plus 3 plus 4, not like that. Vector addition of displacement by the first wave, second wave, third wave and the fourth wave. This much complication is not there in regular syllabus until you are writing some competitive examination. It is not there in regular syllabus. In regular syllabus, they have talked only about this kind of superposition where two waves are traveling in opposite direction. If you see, they both combine and see suddenly the amplitude was increased. Did you feel that? Do you feel that when the waves see coming from right and left, they both together? Yeah, now see, suddenly it will raise the amplitude. Once again they will go back. Once again when they come, see what will happen. Not in this cycle. The cycle will become 0. Now it becomes 0. Now next cycle when they come, once again the amplitude will raise to, see, negative, it will go down, double. Went no? So if this is A and this is A, it will become 2A, minus 2A or plus 2A. That is the range in which it can vary. So we talked about this, and we also talked about how two waves which are moving in opposite direction, when they interfere, then their net displacement is the vector addition of 1 and 2. And we even talked about constructive and destructive interference. We derived the expression actually, if I remember. We derived the expression of y. When we added both, we got the value of final wave equation as y is equal to a sine kx minus omega t plus phi by 2, where a is equal to 2a cos phi by 2. So when two waves are superimposing to become a new wave, its amplitude is 2a cos phi by 2. What is phi here? Phi is the phase difference between them, isn't it? If this is having equation of y1 is equal to a sine kx minus omega t, this is having equation of a sine kx minus omega t plus phi, it means phi is the phase difference between these two waves. So when two waves are interfering to form a new wave, that new wave's displacement will be 2a cos phi by 2 into sin kx minus omega t plus phi by 2. This is the equation of the new wave which is formed by the intersection of two waves. And I also told you about constructive and destructive interference, where I told constructive interference is that scenario when crest and crest are meeting or trough and trough is meeting, whereas in the case of destructive interference, crest and trough or trough and crest are meeting. So if crest and trough is meeting, the net amplitude will become 0, no problem in that. But if crest and crest is meeting, it will become double. So we have found the equation of that also. So if you see A and A is meeting, it is becoming 2A, and then when we relate with this, we get the value of constructive interference as plus or minus 2A, and we find the value of phi. That means we want to know for which phase differences, that is, two waves are traveling, which phase differences will lead to constructive interference. You can easily tell, because when you solve it, you will get the phase differences as 2 and pi. That is, if one wave and another wave is traveling with a phase difference of 66 pi, whether it will be constructive or destructive? Constructive, because it is 2 and pi category, even pi. If one wave, another wave are interfering with a phase difference of 46 pi, constructive, because even pi. If it is even pi phase difference, it is going to give you constructive interference. Same way for destructive interference, when we solve the equation, we got the value of phi as all the odd pi's, that is pi, 3 pi, 5 pi, 7 pi, 9 pi, 11 pi, 2671 pi, 1,21,721 pi, any odd pi. Two waves are coming, having a phase difference of 77 pi, interfering. What will happen? Destructive interference. That point amplitude will be 0. Are you understanding this concept? If two waves are coming, when they are hitting each other, resultant wave will have what amplitude totally depends upon whether it is constructive or destructive. Tell me, Sharan Ram, yeah.
You are saying that this concept applies for this. What is that? The doubt is this applies when the two waves are having same amplitude or different amplitude also.
Different amplitude also can be applied. But in this case, the derivation that we have done is for only same amplitude. Are you getting my point? You can also derive for different amplitudes. So we can take A1, A2 and derive. Are you getting? It can be done. But this equation what we are speaking is actually for the waves are having same amplitude. See, all these things will be extending in 12th standard. Same thing. They will have the heading as constructive and destructive interference. They will call it as bright spot and dark spot, maxima and minima. Those things again I am repeating, they will not teach this much. They will directly go into, you know that when phi is equal to 2n pi, it is going to be bright spot. When phi is equal to 2n plus 1 into pi, it is going to be dark spot. You should know how it came. It comes from 11th standard. Understanding it? Proceeding further. So this question did we solve? I don't think you have solved. Have you solved this question? No. Take it. Everybody start taking the question. The question is, there are two waves, equations are given to you. They are asking you to calculate the resultant amplitude. Simple question, but be careful. Don't say 5 plus 5 is equal to 10. Don't say 5 plus 5 is 10. There are two waves, they are asking you to find the resultant amplitude. The formula you know very well, 2a cos phi by 2, isn't it? So first you have to find the value of phi and then use 2a cos phi by 2, you will get the answer. Everybody, please try, make it fast. Vidyut, why is your video off? I hope you have found the value of phase difference. How much is that? What is phase difference? Phi, what is that? What is? Here the phase, initial phase is pi by 6. In the second wave, the phase difference is, phase is pi by 2. Subtract both, isn't it? Pi by 6 means how much? 30. And pi by 2 means how much? 90. So when you do 90 minus 30, how much you will get? 60. 60 means how much? Pi by 3. So what is the value of phi you are going to get? Pi by 3. How I have got you understood? The phase of first wave is pi by 6. The phase of second wave is pi by 2. Phase difference between them is how much? Pi by 2 minus pi by 6, which will give you pi by 3. I hope you have understood this. And we know very well that resultant amplitude is given by 2a cos phi by 2. Question is over actually. 2 into what is a? A is 5, isn't it? And cos, what is phi? Pi by 2 and the 6, 3 is there, so pi by 6. What is cos pi by 6? Half. Cos pi by 6. Root 3 by 2, I think.
1 root 3 by 2, sir.
1 he is saying. 10 into root 3 by 2. So answer will be 5 root 3 units, whatever. Let us check this answer is right or not. Is it clear to you how I have solved? This kind of question will come. Simple question it is. They gave, see, understand the wave equation. Y is equal to a sine kx minus omega t plus phi, initial phase. Second wave, y2 is equal to a sine kx minus omega t plus phase of this wave. We found the phase difference and then we put in this formula to get the value of resultant amplitude, which is equal to 2a cos phi by 2. So I hope all of you are clear in this. Let us see the answer given here.
Small doubt, sir.
Please ask me.
Sir, how did we get phi as amplitude here, sir? Because I don't get it, sir.
See, what are the equation of wave? Equation of wave that you have studied is y is equal to a sine k minus omega t. And second equation we took as a, or we can say take the a to sine kx minus omega t plus phi, right? This only we did the previous time.
Yes, sir.
So this, in this case, both these were same. Here also it is 5, here also it is 5. So I am taking it as a in both the cases.
Okay, let's say one is 10, one is 5, sir. So what will be a, sir?
Then is good question. He is saying that if this is having as 5 and this would be having as 10, then what you will take in this case? Whether you will still take a as 5 or you will take a as, that is the question. Am I right, Abhinand?
Yeah, sir.
Okay.
Yeah.
So as I said before, you asked the question that this equation that we have derived is purely based upon assumption that both the amplitudes are same. If both the amplitudes are not same, let me tell to you. You will learn in higher class, but let me tell you to you now itself. Shall I tell you? Please pay attention.
Absolutely.
Yeah. So I'm doing it here itself. So let me assume there are two waves. One wave is having y is equal to a1 sine kx minus omega t, right? And y2 is equal to a2 sine kx minus omega t plus phi, some phase, right, Abhinand? Now a1 is the amplitude of the first wave and a2 is the amplitude of the second wave, right? So resultant amplitude AR will become equal to what? See, amplitude is a vector quantity. Once again, it will become root over A1 square plus A2 cos phase difference, that is phi. Are you getting? So in that case, how do you find? Suppose the question would have been 5 and 10 here, as you asked. Then the answer would have been root over 5 square plus 10 square plus 2 into 5 into 10 into cos. What is 5 we got? Pi by 3. Isn't it? Am I right?
Got it, sir. That's it.
Solve this, will get the value of AR. So in the case, if there are two different amplitudes, we can use this vectors to find the resultant amplitudes. Getting it, Abhinand?
Got it, sir. That's it.
Okay. If it is same amplitude, we can use directly 2a cos phi by 2. No problem in that. Anybody has any doubt, ask me. Is it clear? Can I proceed further? Okay. Now we are going to enter into some interesting part. Again, interesting for those who are listening, who are wanting to learn. If you are coming because of somebody's force, then you cannot learn. So please pay attention. Now we are going to talk about the reflection of waves. That is, wave is going to go, hit something and get reflected. You know why we are learning all these things? Because you will learn in higher class, even light is a wave. Light is also a wave. So this will be applied to light also in the next 12th standard. Anyhow, so reflection, up to now we have just considered the waves moving in unbounded medium, like it is just moving freely, nowhere it is going to go and hit. But now we are going to talk about a wave that meets a boundary, like wave is coming and hitting the board. Board may behave like a rigid boundary or board may behave like a free boundary. That is, it is allowing it to move along with it, or it will stop, like wall, rigid. Example I am giving you. So now first we will talk about rigid boundary. So what I have done, you see, I have taken a string, okay, to represent the wave formation, and then I have used a clamp to tie it at one end, so that the wave produced is meeting a rigid boundary. Are you getting my aim? My aim is to make the wave meet a rigid boundary, fixed boundary. You cannot move it. So what happens, you see, the moment you are giving, yes, so the moment the wave starts, why it is not? Yes, see now. So wave hits the rigid end, what happens? It reverses the direction. So did you see what happened? Once again, see carefully. The wave goes, I will start from beginning once again. Yes. So now if you see, when the wave started to move from left towards right, why there is some issue in this slide. See now, it goes, hits this rigid end, then how it produces? Something which is having a phase change of how much? Phase change of 180 degree. From a wave coming like this, it became down and went, isn't it? Have you seen it? If you want, I will show you once again. If it comes, there is some error in this GIF. goes, hits the rigid end, reverses the direction. Now it became two waves. One wave moving towards right, one wave moving towards left. We will talk about it, what happens if they are meeting. But now what a rigid boundary is doing, a rigid boundary or a solid boundary is making a phase change of 180 degree on the reflected wave. So the first wave which was coming from the left was a incident wave. Incident wave came, hit this boundary, it became reflecting. When it became reflecting, that time it had a phase change of how much? 180 degree. Now can you tell me by your knowledge till now, if I take the equation of progressing wave as y is equal to a sine kx minus omega t, what will be the equation of reflected wave? This is incident wave, I am asking reflected wave. Tell me, y will become equal to a sine kx plus, anybody wants to add something in this, or it is okay? Nowhere you are adding the phase change, you are just adding that minus became plus. Plus? Obviously yes. Are you getting why plus phi? Because now the phase got changed by 180 degree. Yes. And so the equation will change. They would have given that also, maybe. Okay, now they are telling conceptually what happens inside. So if you see, when the wave is arriving at the rigid end, what happens you see? It will come and this wave is going to give a force at this point. That force, how it is going to act you see? Towards upwards direction string. This point is coming and hitting this boundary, it is giving a force on the string. Now for every action there is an equal and opposite reaction, there will be a reactive force in the opposite direction. How it will be acting? See down. And because of this, there is a reflected wave produced which is having a phase difference of how much? 180 degrees. So what happened? Incident wave came, hit the rigid boundary. Since it is rigid, strong, it immediately gave a force on the rigid boundary. Force, action, reaction came. Reaction made a reflected wave in the opposite direction. So there was a phase change of 180 degree. This is what happens technically inside the wave. So here, if you take the equation of incident wave as a sine kx minus omega t, the equation of reflected wave, as I told you before some time, it will be a sine kx plus omega t plus pi. Understanding? What is important in this thing is this only. Equation of incident wave, y is equal to a sine kx minus omega t. What is the equation of reflected wave? Y is equal to a sine kx plus omega t. Why kx plus omega t? Because it is going in negative x direction. And y plus pi, it is a phase change of 180 degree. If you are understanding this, copy it fast. Last this thing. This is only important in this slide. Write the equation of incident wave and write the equation of reflected wave. Make it fast. What happened, Shweta? Not definition, I guess. They were the same thing they would have written, that when it comes, it will have a phase difference of 180. Okay. When a wave gets reflected at solid boundary, the reflected wave has the same shape as incident pulse, but it suffers a phase change of pi. Shape remains same, but there is a phase change of pi. That's what is written here. So I hope you have written the equation. Have you written? Did you write? I am showing once again. Have you copied? Can I proceed further? I'll wait. Can I proceed?
Yes, sir.
Thank you. So now we will talk about a free boundary. Are you feeling the difference between a rigid boundary and free boundary? In the case of rigid boundary, I held the end with a clamp. Now what I am doing? I am just keeping it inside a rod. When this comes, it will also move along with the wave, isn't it? I hope you are feeling it practically what will happen. In the previous case, I was holding it tight. Now what I am doing, I am allowing it to move in this free end. So it will come. When the wave reaches here, it will go above and go down as the wave goes. Let us see what happens. See. So now we are making the wave to get reflected by a free boundary, and let us see what happens. So when the wave starts, goes, it makes the end also to move and come back. So what will happen? There will be no phase change here, because we allowed the end itself to move up and down. In the last case, it was rigidly fixed here. So it did not allow the movement of the end. But in this case, what is happening? The moment you gave a wave, you allowed the free end itself to move, and so when the wave is getting reflected, it has not only the same shape, it also has the same phase as the incident wave. So you tell me, if y will become equal to, that is, incident wave is having equation of a sin kx minus omega t, what will be the equation of reflected wave? Y is equal to y 2m, a sin kx plus omega t plus y, no pi here, nothing, no change in phase. Are you getting what I am trying to tell? In the previous case, plus x direction became minus x direction after reflection, and there was a phase change of 180 degree. So if the incident wave was y is equal to a sin kx minus omega t, reflected wave became y r is equal to a sin kx plus omega t because of positive negative x direction plus pi because of phase difference of 180 degree. Increase only for managing, it is increasing, later it is increasing, as a see, only for that instant it is increasing, looking increased to you. Sorry, yeah, see, going, this is the amplitude line, okay. For that instant goes above, after that you see, when they are meeting only it is going above. You may think that when they are meeting it is becoming 2a only, sir. Yes, true. We will talk about that. When they are meeting, what happens? I am not concerned about meeting now. I am just concerned about when the wave is hitting this point, then reflected wave comes in which shape? Reverse shape it comes, and there is no phase change, isn't it? As you think, yes, at when they both meet together, I am seeing there is a increase of phase. See, it is becoming double. Becoming, I accept. But when it is becoming double, we will talk about that now. Superposition it is. First understand what happens if the end is there. Up to now, before this slide comes, we were talking only about there is no boundary. Now we came to boundary. Two boundaries are there, rigid boundary and free boundary. If it is rigid boundary, incident wave will go and reflected wave will have opposite direction and a phase change of 180 degree. Free end is there, the reflected wave will have opposite direction but no phase change. Is it clear? So the same thing will be written. Now concept wise you see, the pulse came, hit it. So what will happen? We allow this wave to climb on this, isn't it? If we allow the wave to climb on this, it tries to climb, and once again after reaching the maximum it comes down and starts going in the same direction back how it came. So there is no phase change. Direction obviously will change it. After all, it is a boundary, it has to come back, but there is no phase change compared to the previous time. So if you are giving the equation of incident wave as a sin kx minus omega t, the equation of reflected wave will become a sin kx plus omega t. No phi here, no pi. Got it? So I hope you are clear. This kind of questions can come. Difference between a rigid boundary and a free boundary. Rigid boundary changes the direction as well as changes the phase, but free boundary just changes the direction. There is no change in the phase of the wave, it remains the same. Understood? Copy fast. I will go to the next page then. We are very slow. Time 1 hour remaining, Shraddha. Want to go now? You can go. Who has stopped? Shall I call your father? I will call today. Wait. That day I met you. I should have met your parents also. Fast. What is the problem? Anything you have commitment tomorrow? Then feeling sleepy? Exams are still running? What exam you have tomorrow? Okay, what is there in that? Don't study, don't get marks. You should study before and be ready. What is this? You want to go? Okay, yaar, if you are going to get less mark, any problem? I'm alive. I should not speak all these things. Okay. What you want me to tell you to go home? Then focus on the board. Don't be in that stress of biology exam tomorrow. Don't worry. God is there. God will help you. Yeah, tell me, Pratap, something you are asking? You also have exam.
Nothing serious, sir.
Something is there? Tell me, man.
No, sir. I completed biology exam day before yesterday.
Okay. Now
Yesterday.
exams are over now or still it's going on?
No, sir. Tomorrow is my English exam and Friday is my physics.
Okay. See, that boy is sitting and without any problem he is sitting.
Sir, English exam only.
Okay, so she is saying English exam only, no. Man, Pratap, if tomorrow would have been bio exam also, you would have come, no? What, Pratap?
Yes, sir. I came for class. I came for chemistry class.
See.
I also took the monthly test.
Yeah. Man, there should be zeal to study. What, Aviran, what you are commenting? Comment. Yeah.
I also have biology tomorrow, sir.
Oh, see. One more bio is there. But if you have interest to learn,
Bio person is vast.
yeah, bio is vast, I know. Okay, shall we continue? If you allow me to move, I can finish fast. At least you can go 10 minutes early. Shall I? Okay, you're writing notes, no? Okay. Fine, good question. Interesting question. Please pay attention. There are two shapes here. One is a triangle, one is a kind of square block or something. They are saying what will be the shape of reflected pulses. These pulses are going and hitting this boundary. If it is rigid boundary, what will be the diagram? If it is free boundary, what will be the diagram? Draw and show it to me. At least offline people, draw it now and show me. Are you getting what is the question? Wave is approaching towards right. After it hits, if it is rigid boundary, how it will come back? Simple question. How it will come back? Say loudly. Inverse. Yeah, that's all. Draw and show, no? Draw, na? Rajat, you drawn. Free? Incident wave they have given. Draw the reflected wave. What are you drawing, Shweta? You separated the square and the triangle. Why here? Nobody asked you to separate. Together. Anybody who has drawn in the online class can show the notebook like this to me. I can see actually we have a big screen. I can see. You can make the view to be bigger. Show me. Why you separated this two? Make it together coming back, no? All of you are separating it. Why you are separating it is... Don't separate it. It goes, hits. When it comes back, what will happen? Some people are showing, Pratap is showing. Can you make the screen bigger? Console room. Pratap's screen, can you make it bigger? Spotlight something? View you can change. No. Yeah, from their view. Multi-speaker. Yes, and now you can spotlight that boy. Those who are showing answer. Leah Varshni also you can spotlight. Whoever is showing the answer, you can spotlight them for 1 second. Yeah. So, one thing you have cut, Pratap, whether it is cutted...
That is strike out, sir.
That is striked out, okay. Okay, good. Show your answer. Abhinan answer you can zoom. Yes, good. Anybody else who is showing Manoranjan? What you have made Manoranjan, man? Okay, so for second you have made like that. Okay, fast. Why second? In second wave you have left our box, that is square. Only triangle you have drawn. Leah Varshini you are showing, right? 1 second, can you show? You have changed direction of this itself, string itself. Your answer may be right also, but you have changed direction of the string. You have made the boundary to go towards left. Don't do that. Let the boundary be towards right itself. You can remove the spotlight. Thank you. Okay, let me tell the answer to you. Check your answer, it is correct or not. So when the wave comes and hits the rigid boundary, it will have 180-degree reflection. Many will do this. They will draw triangle first and square next. Wrong, 0 marks they will give, because square hits first, it will go first. So there should be square and then a triangle. That is the case of rigid boundary. What will happen in the case of free boundary? Square will go and then triangle will follow. No phase change. Simple question, isn't it? Anybody has doubt in the answer that I have told? Anybody has any doubt in the answer that I have told? Clear? Can I proceed? Yes, Shweta, we'll proceed, don't worry. Next, we'll talk about refraction of waves.
Sir, before we proceed, excuse me, sir.
Please, Pratap, tell me.
I can see the other person's screen spotlighted. I think it's not removed yet.
Yeah, so I can't see your screen fully.
Okay, you can make the view to be I think you have to change the view. Remove spotlight and change the view
I
to.
continue, sir.
Now it's fine, sir.
Now you see, man. Now it is fine, I think. Is it clear to everybody? Now I am visible to everybody.
Yes, sir.
Okay, thank you. Coming to refraction now. Reflection is some incident wave is going, hitting and getting reflected. Now we will talk about refraction. Refraction means the wave travels from one medium to another medium. Once again, for refraction also we should have a boundary, right? Remember the boundary. So there is a boundary going to be there, and the wave is going to move from one boundary to another boundary. Now the boundary can be again of two types. A rigid boundary can be there or a free boundary can be there. Now how we define rigid boundary and free boundary for this kind of thing? By taking different ways of string. Like for example, if you are having attachment of light string with heavier string, like you have a thin wire, then you have a thick wire. So when the wave is going through the thin wire, when it hits the thick wire, it is actually a rigid end for the wire. And suppose the wave is coming like this, from thick wire to a thin wire, then it will be like moving from what medium to what medium? It will be going from hitting here, it will become like a free medium. Yeah, something like that. Rare, dense, rare. Isn't that way also you can think. So what happens, let us see. Wave comes, hits the boundary. Now tell me, that heavier string will behave like a rigid boundary? If it is rigid boundary, what will happen? Phase change as well as direction change. But we are talking about refraction. Yes, very good. What will happen? It will go, some part will reflect back, some part will refract into the medium. The one which refracts.
Sir, can I think of this right?
Yeah, go ahead. Pratap?
Sir, can we think of like a partial rigid end?
We have to assume it.
Not completely different.
It is rigid only. But what happens, when the wave hits this point, since it is allowed to go in the front, it has two parts now. Some part of wave will get reflected, some part of wave will get refracted, because we are allowing it to move towards right. Understanding, Pratap?
Yes, sir.
So let us see, by diagram you will understand. See what happened? It went, one part got reflected, one part got refracted. But if you see carefully, you will realize the amplitude reduced. Check once. Wave is coming, incident wave is coming, hitting. Now see reflected wave and refracted wave, its amplitude got reduced. Because of what? Rigid end. And some part has gone refraction, some part has gone reflection. The red part is reflecting and the blue part is refracting. So what happens? I hope you are able to understand the scenario in both the things. So if you see, reflected pulse is inverted because heavier and behaves as a string rigidly attached to the support. Are you getting my point? This is getting a phase change. Why it is getting a phase change? Because it is behaving like a rigid support. Now what happens in vice versa? When a heavy string is attached to a lighter string, wave comes, it hits that end. Now it is hitting a free end. So it will smoothly transfer there and that wave will once again go back. But if you see once again, the amplitude of the incident wave and amplitude of the refracted wave is not same. It is reducing because a part of the wave is only refracting, a part of the wave is coming back. Since the wave is dividing in two different parts, its amplitude will obviously reduce. Tell me.
That part of the wave getting refracted and part of the wave getting reflected.
It will
Always.
always happen if there is a permission for the wave to move ahead. If I would have kept a wall here, then obviously it cannot happen. It will come back. But now I am allowing the wave to move, so refraction will take place. I am allowing the propagation of wave from one medium to another medium. Why I am saying medium? Because here it is heavy string, here it is light string. They are different for the wave. Are you getting my point? So the same thing happens. Reflected pulse is in the same phase because lighter end behaves as a free end. But one thing I have mentioned there, see, reflected and the transmitted both pulse have a smaller amplitude than the incident pulse in both the cases. That you have to note. In both the cases, when we were learning only about reflection, we not reduce the amplitude. Wave was coming, hitting the rigid boundary, reflecting back, opposite direction, 180-degree phase change, but no change in amplitude. Y was equal to A sin omega t minus kx for incident wave. Reflected wave was Y is equal to A sin omega t plus kx plus pi. In the case of reflection at free end, incident wave was having equation Y is equal to A sin kx minus omega t. The reflected ray had the equation Y is equal to A sin kx plus omega t, no pi. Am I right? But in both the case, A was A only. Here what will happen? If incident wave is having Y is equal to A or A1 sin kx minus omega t, reflected wave will have YR is equal to A2 sin kx plus omega t plus pi in the case of rigid, that is from light to heavy string, and from heavy to light it will become Y reflecting is equal to A2 sin kx plus omega t, no pi will come. But refracted wave in both the case, whether it is the previous case light to heavy or heavy to light, the equation of refracted wave will be, if incident wave is having Y is equal to A1 sin kx minus omega t, it will become Y refracted is equal to A2 sin kx minus omega t only. It not become plus omega t also, because there is no change in direction, same direction, and no phase change obviously. I hope you are getting what I am trying to tell. And in this case, once again refracted wave has same equation, Y, that is Y refracted will become equal to A2 sin kx minus omega t. Only A1 will become A2. But for reflected, it will become kx plus omega t and plus pi in the case of light hitting heavy string. Is it clear to you? Is theory clear to you? Boundary effects are clear to you? How the boundary effects behave is clear? Okay. If yes, then we will move ahead and we are going to learn about standing wave formation. Very, very, very important in this chapter, because standing wave formation only helps you to understand the organ pipes, the strings, everything. We are entering the last part of this chapter slowly. So, Shweta, if you want to go, you can go. I am serious on this. Okay? If you are mentally absent, there is no need of sitting in the class. If you feel too much stressed about tomorrow's bio exam, then you have brought bio notebook, go and read in some other classroom. Nothing you have brought, then go home and read biology. I don't want to sit you forcibly, because it is not going to give any result. If you are in the class, be in the class mentally. If you feel, no, I am having tension of tomorrow's bio exam, I am allowing you, go. It is on internet now. Your father also can listen. You can go and read for biology. Your wish. I am giving a chance to you. I will not mind it. I don't think that what he will feel, he will scold me, nothing I will do. You see your convenience. Coming back. So, we are talking about standing wave. So, now what is a standing wave? First you write definition. Everybody please write fast. So, the definition is when two identical waves are moving in opposite directions in the same medium, combine and form a steady wave pattern, this wave pattern is known as standing wave. It is also called as stationary wave. You can mention that line also. In some books they will write stationary wave formation. So, standing wave is also called as stationary wave. What is the meaning of that? Two waves traveling in opposite direction in the same medium. When they combine, then the wave becomes standing. Now it is very like, how is it possible? Moving wave combining to become a static wave. Let us see how it is possible. Can I proceed?
Yes, sir, again, sir.
Make it fast, make it fast. Yeah, I'm waiting, make it fast.
Sir, done, sir.
Everybody done? Okay. Shall I continue? Shall I? Okay. So, now pay attention to understand the concept. If you see this, I don't know red is visible to you or not. Next diagram will be little clear. So, now what is happening? The incident wave is moving towards right, hits a boundary. It is hitting a rigid boundary. What will happen? Phase change will happen, reflected wave is coming. Now, reflected wave and incident wave are superimposing. Slowly see what is going to happen. Slowly, we are going to get a black color wave which is actually just moving up and down, feeling that? This is what was happening that time when you are asking, sir, amplitude is becoming double. Yeah, it is becoming double. But how it is behaving, you see. Red wave moving towards right, blue wave moving towards left, but the resultant wave moving up and down, up and down. You are feeling it? Combination is taking place like that. Superposition of reflected wave and incident wave. Yes, anybody is asking something? I will show you another. This is little better diagram. It was like yellowish. Now see. Blue one is incident wave, red is reflecting wave. After they combine, what it becomes, you see? Standing wave or stationary wave. How it is moving? Up and down, up and down. Are you feeling? One thing I will tell you, here, if any particle is there, okay, if I draw a line and draw particle at all the points on the line, can you say that a particular particle will not have any motion? You cannot say. Every particle will go up, then come down, then go up and come down. Am I right? Are you feeling what I am trying to tell? If you are confused, stop me. I am saying that in the incident wave or reflected wave, if any particle is kept on the string, any particle is kept, that particle, wherever it is kept, must go up and down, up and down, up and down. But see standing wave, if a particle is somewhere, where I will show you, when they combine, yes, now you see. If a particle is somewhere here, see this point where I am keeping a pen, it will always have zero displacement. If a particle is, I will show one more point, combine, yeah, now you see, particle somewhere here at this point 10, it will always have plus 0 minus, 0 plus 0 minus, double. But there are points where we have zero displacement. Those points are called as nodes. What is a node? Nodal points are those points where displacement is always zero, and node is forming on stationary waves, standing waves. Now we are entering into a very practical topic of this chapter, where everything that you see, tell me.
Nodes and internodes can,
Tell me again, Pratap.
these nodes and internodes can be seen in microwaves, right, sir?
Microwaves.
Yes, sir. Practical microwave ovens use the same, these kind of waves where the node points heat up the food.
Exactly. You are talking about the working of microwave oven, right?
Yes, sir.
Yes, true. When microwave ovens are used, what is a microwave? It is like electromagnetic radiation, electromagnetic wave. Electromagnetic waves produced by microwave, when they are superimposing and at the nodal points, as he said, it is creating not a nodal points, nodal and antinodal points. So at nodal points you have zero displacement, Antinodal points you have maximum displacement. Now, okay, we'll go to that part, then I'll speak about it. If I go next page. So now let us talk about the equation of standing wave. Once again, we came to the numerical part. Theoretically, you understood, right? Theoretically, incident wave is coming, reflected wave is coming, and they superimpose to each other. What they form? They form standing wave. It is also called as stationary wave. So for a stationary wave or standing wave formation, what you need? You need two waves having same amplitude, moving with same velocity in opposite direction in same medium. The question may come like, what are the conditions required for standing wave formation? Conditions are, the waves must be moving in same medium, waves must have same amplitude, waves must have same velocity, but they should have opposite direction. If all these conditions are satisfied, then they will meet and form stationary wave. Today you have to meet, women. You also want to meet me today? Otherwise, you can leave one chair and sit this side. So you must meet me today. Today is a good day for you. Okay. So I have written the equation of the incident wave, A sin kx minus omega t, as I said to you, and A sin kx plus omega t is the second equation of the wave, that is coming in the opposite direction. Now, superposition principle says that net displacement will become equal to y1 plus y2. If I do that, once again same thing we did in the previous class, remember, sin A plus sin B. If I take A common out, it will become sin A plus B plus sin A minus B. That way you can say, or you can say sin A plus sin B. For that you will write 2 sin A plus B by 2 A minus cos A minus B by 2, isn't it? That identity we are using here. That is, if I take A common outside, it will become sin kx minus omega t, sin kx plus omega t. If I take this as A, this as B, it becomes sin A plus sin B. Sin A plus sin B is 2 sin A plus B by 2 cos A minus B by 2. I hope you know this mathematical identity. By that identity, when I solve, I will get the equation as y is equal to, see, if you solve this, kx will get cancelled, omega t gets cancelled, like that, kx will get added, sorry, omega t gets cancelled. Here if you see, kx gets cancelled, and omega t also gets cancelled, I think. Some check there, what is the thing? Yeah, it will get added, yes, it will get added up. So you will get finally 2a sin kx into cos omega t. This is the resultant equation of standing wave. So what is the standing wave equation? 2a sin kx cos omega t. Is it clear? Is it clear? So here what is the amplitude you are getting? 2a sin kx you are getting as the amplitude of the wave. How much is that? 2a sin kx. Please pay attention. This term generally is taken as the amplitude of the wave. And how much is that? 2a sin kx. This is the amplitude of standing wave or stationary wave. Please copy it fast. Amplitude of stationary wave is 2a sin kx. K is propagation constant, A is amplitude, x is distance travelled by the wave. Make it fast. Let me know when you are done writing. Done writing? Done. Make it fast, make it fast. Finished, Advait? If you allow me, I'll go to the next slide. Can I? Online people? Okay, thank you. I am moving ahead. If something is there to be written, you can copy it later from the video that I am going to send you. Anyhow, shall I proceed further? Yes. So now, you can see here the net amplitude, there is each particle of the medium vibrates in simple harmonic motion with an amplitude of 2a sin kx. This is the amplitude going up, down, right? Now, we are going to talk about, this is the standing wave formed. I hope you are able to see. And as I said you before some time, you can have clear nodal points here. That is, these points are nodal points where never any displacement takes place. Whereas, these points are called as antinodal points where you have maximum displacement taking place. I hope you are understanding this. The points between two nodes is called as antinode. Antinode will have maximum displacement. Node will have zero displacement. That is the nodal point. So, if you see this graph, we have got the equation as y is equal to 2a sin kx cos omega t. So, now let me talk about this to you directly. Yes, difference between a travelling wave, that is a propagating wave, progressive wave, and a standing wave. So, progressive wave moves like this. Are you able to feel? From first day I am talking about this. Move, it looks like it is moving towards that. If you see carefully, this green remains here only, just going up and down, but gives a feeling to you that moving towards right, because energy is propagating towards right only. But standing wave, how it is? See, up and down, how it is going. Next, about disturbance. So, disturbance produced in a region propagates with definite velocity, but if you see in standing wave, disturbance is confined to a region where it is produced, obviously. You can write these differences for your school exam sake. So, all the particles have same motion, but in standing wave, different particles obviously have different motion. So, if you see here, I will tell one more thing, please pay attention. If I take any other point than node and antinode, you will see that that particular point, the particle can displace only this much. It can never have maximum displacement. I hope you are getting this. See, in this case, this green point you see, always it gets chance to go become amplitude also, become zero also, negative amplitude also. Any red point you take, this point, if any point you touch, you will see that it is undergoing all the points, 0, 1, 2, 3, 4 maximum, then once again 0, negative maximum, once again 0, positive maximum, all the points. But here, different points have different limits. Only the antinodal point can have maximum displacement. Nodal point, 0 displacement. Any other point, only the displacement what is decided by the standing wave formation, that only that much displacement can have. Are you clear in this? That is third point. The fourth I am writing as, there is no instant when all the particles are at the mean position. Obviously, right. Can you see here, any point you are feeling that all of them have come in the same straight line? Never. Wave starts, all the particles can never come in the mean position. But here you see, for 1 second, now see, it came in mean position. Once again, mean position. Like for 1 second, you are seeing the mean position is coming. Nodal, antinodal, once again everything in mean. Once again everything goes like that. Are you able to feel? For a particular second, all the particles are touching mean position. But here, no time you can see that all the particles are at mean position. If something is at mean, something is at extreme. But in standing wave, you have that condition where all the particles also can come in the mean position. Obviously, all cannot go extreme because nodal points are there. Last point is, energy is transmitted from one region of space to another. Here, energy of one region is always confined to that region. Are you feeling it? You can feel very clearly that there is energy transfer felt from left towards right. Anything you are feeling like that energy transfer? No, it is confining to this much space only. I hope you understand. You may ask then why it is used for. If there is no energy transfer, why it is used for? It is used for transmitting energy in this way. Are you getting? Whatever is present in this path, it will hit it, no? Towards up, towards down. When you are playing a guitar, when you are playing a violin, when you are playing any musical instrument where string is involved, you know what is happening? The same thing is happening there. Standing wave formation is happening. We will talk about it today. Today in the class, we will talk about it also. Have you written this differences? Everybody has written all the different differences? Fast, fast, fast. Don't take much time. Yes. You can't see the first point. Last point you cannot see. Now you can see?
Sir, can you just say the
Last point is energy is, for the travelling wave it is, energy is transmitted from one region of space to other. I will repeat, energy is transmitted from one region of space to other, and for standing wave, energy of one region always is confined in that region. Always is confined in that region. Written, Kirti? Okay. Can I proceed further? Make it fast. If you are missing something, don't worry. We have recording. You can write later also. Because I don't want to take long. I am proceeding. If something you have missed, don't worry. You will get a chance to write later also. Fine. So now I am talking about the nodal point and anti-nodal point. You should understand the expression, mathematical. Once again, we are going to analytical treatment of nodes and antinodes. So I said you, nodes are those points where the amplitudes are always 0. What are nodes? Those points on standing wave where the amplitude is always 0 are called as nodes, and it is represented by that n, capital N letter in the waves. Now let us talk about the mathematical expression of nodes. So just now I told that amplitude of the wave is what? A is equal to 2a sin kx, isn't it? If that should be 0, then what will happen? Sin kx must be 0. Guys, I will give time for writing. Please, 2 minutes, pay attention. So if sin kx is equal to 0, what should be the value here? Sin 0 is 0, or
0.
only not only 0, 0, pi, 2 pi, 3 pi, 4 pi, n pi. So can I write kx is equal to 0, pi, 2 pi, 3 pi, 4 pi, n pi. And then what will be x? X will become 0, k will come in denominator, it will become pi by k, 2 pi by k, 3 pi by k, 4 pi by k, like that. Can I? Now you see, general expression of x became how much? It became n pi by k, isn't it? It became. What is k, by the way? You know, k is 2 pi by lambda. So if you want to write x is became equal to n pi divided by 2 pi by lambda. Pi gets cancelled. X became equal to how much? N lambda by 2. And n, if you start from 0, then it will become n is equal to 0, 1, 2, 3, 4, 5. It means, what are the nodal points? Nodal points are at 0, obviously it is there, 0. Then second node will be where it will form? Second node will form at lambda by 2. Understand this very deep thing. Third node will form where? When you put 2 lambda by 2, there is lambda. So 0, lambda by 2, lambda, 1.5 lambda, 2 lambda, 2.5 lambda, 3 lambda. Yes, tell me, man, Abhinand.
Like pi by 2, pi by 3, pi by 2.
I am not talking about pi.
I'm just saying. Like
Yeah,
that.
yeah, tell me.
Same formation, sir.
Yeah. The same progression.
Yes. Is it clear? I hope it is clear. Is it? Same thing they would have written here also. So lambda is equal to 2 pi by k. So then you are going to get x is equal to n lambda by 2. That is, you are going to have 2 consecutive nodes at a distance of lambda by 2. This kind of questions are coming in the examination. So you can see first node at 0, second node at lambda by 2, then lambda, then 3 lambda by 2, then 2 lambda, then 5 lambda by 2, then 3 lambda, 7 lambda by 2, 4 lambda. Are you understanding? Instead of saying 7 lambda by 2, I can say that 0, 0.5 lambda, lambda, 1.5 lambda, 2 lambda, 2.5 lambda, 3 lambda, and so on. It means between two consecutive nodes, what is the distance? Lambda by 2, half lambda. Are you getting? Node distance, remember this, nodes are forming in stationary wave at a distance of lambda by 2. Clear? And by seeing itself, you can tell where will the antinode form? Middle of that, lambda by 4, isn't it? Are you able to feel it? The first antinode will form at lambda by 4, then it will form at here. What will be this point? 3 lambda by 4, isn't it? 0.75 here. This is 0, this 0.5, it is 1, 0.5 it will be 0.75, right? So 3 lambda by 4, like that it will proceed. Let us check, verify it. Shall we go to the next page? Shall I go to the next page? Written this, no need of writing. Written, okay. Can I go to the next page, guys? Those who are there in online, permit me. Written? Okay, quick. So next we are going to antinodes. So antinodes are the points where the displacement or the amplitude is largest, isn't it? So we are going to find the points of antinodes also. How will you find that? Once again, 2a sin kx will become equal to 2a. So if it is going to become 2a, then sin kx will become equal to 1. Which value of sin gives 1? 90, pi by 2. After that, 3 pi by 2, 5 pi by 2, like that n plus 1 by 2 into pi, or 2n plus 1 by 2 into pi, whatever you want to say. So we got the expression of kx or x as 2n plus 1 by 2 into pi, isn't it, by k. Do you agree? General expression of distance of antinode. Put value of k as 2 pi by lambda, it will become 2n plus 1 by 2 into pi. What is k? 2 pi by lambda. Pi gets cancelled. So I will be getting x is equal to what? 2n plus 1 by 4 into lambda, where n from where it starts? N starts from 0, 1, 2, 3, 4 and so on. So you can put 0 and check, it will become lambda by 4. Put 1 and check, it will become 3 lambda by 4. Put 2 and check, it will become 4 plus 1, 5 by 4 into lambda. And then it will keep on increasing. Are you getting? We can easily find the points of antinodes. It will be written here also without me writing. Yes. So x is equal to n plus 1 by 2. If you open, it will become 2n plus 1 by 2, whatever, into lambda by 2. Right? This is the point of antinodes. So if you see distance between them, once again here also we will get lambda by 2 only, no? Because it is lambda by 4, it is 3 lambda by 4. 0.25, 0.75. Subtract, how much you will get? 0.5 only you will get. Here it was 0.5, subtracted you got 0.5, distance between two nodes. Antinode at 0.25, second antinode 0.75. 0.75 minus 0.25 gives you how much? 0.5. So between antinodes also it is lambda by 2 only, and between nodes also it is lambda by 2 only. But locations are different. Location of node becomes 0, lambda by 2, lambda, again 1.5 lambda, 2 lambda and so on. But location of antinode is starting from lambda by 4 only. Lambda by 4, 3 lambda by 4, 5 lambda by 4, 7 lambda by 4, 9 lambda by 4 and so on. Is these things clear to you? You should be very clear in nodal points, antinodal points. I hope it is clear. I hope. Can I take it like that? Can I go to the next page? Can I go to the next page?
Yes, sir.
Okay. I am proceeding further. If you want to copy, you can copy later. Please. Yes, a question is there. Try to solve it. Transverse displacement of a string clamped at its both end is given by, they have given equation 0.06 sin 2 pi by 3 x cos 120 pi. By seeing question itself, we are losing the interest in solving, right? But that is how the 11th and 12th is here. You cannot give up by seeing a question. Try it, simple question only. They have given length, mass, everything. Okay. So try to find the first expression is You have to find does the function represent a travelling wave or stationary wave? Tell fast. This you can tell without even solving. Whether this is a progressive wave or whether it is a stationary wave.
Stationary, sir.
Obviously stationary. Why? Because it is in the format.
Cos and sin.
Yes, which format it is? It is in the format of y.
And cos, the-
Yeah, sin, or you can say the form is y is equal to 2a sin kx cos omega t. That format only it is there. Cos omega t, and this must be 2a sin kx. K is 2 pi by 3. Everything you got from here. I told the answer itself. Isn't it? 2a is equal to 0.06. A will become equal to 0.03 over kx. K will become equal to 2 pi by 3 over omega will become equal to 120 pi. 120 pi. So 120 pi is omega. Now what they are asking to find? Interpret the wave as a superposition of two waves travelling in opposite direction and find the equation of each wave. You can find, because equation of each wave, you know, it is y is equal to a sin kx minus omega t and y is equal to a sin kx plus omega t. You can find a from here, you can find omega from here, you can find k from here and make the equation. Interesting question. Do it here. Finish it fast. Finish it. I told the answer itself. And what is the wavelength? You can find easily, because 2 pi by lambda is equal to 2 pi by 3. 2 by 2 pi gets cancelled. Lambda is equal to 3. I told the answer. Frequency, what will be that? 2 pi nu is equal to 120 pi. So from there you can solve and get the value of nu. Speed also you can find. When you have frequency and wavelength, you can find speed easily. Simple question. What are the width? Hang. Memory is full. What is happening? Solve it fast, man. Simple question. He is thinking why they have given length and mass. Okay. I hope you are solving this question. First part is, does this function? Don't write question and waste your time. Directly go for understanding the answer. Okay. Why to waste your time writing question? So obviously the first part is, yes, this equation is similar to what they have given. So it is a stationary wave. First question over. Second part of the question was interpret the wave as superposition. So we have to find the value of all the things I told you already. So you have to find the value of A. A will become equal to 0.03. Check. Yes. Omega is 120 pi and K is 2 pi by 3. So put in the equations and get y1 is equal to how much? 0.03 sin 2 pi by x minus 120 pi t, and y2 is equal to 0.03 sin 2x 2 pi by 3 x into 120 pi t. See, it looks very lengthy, but do you think question is tough? Damn simple question, isn't it? 5 mark question comes and all, you can enjoy. If this question comes 5 mark, you can have a good day that day, like how today Sri Ravinas is having.
I got similar question. I didn't have to test it.
You had a similar question in the exam.
Yeah, but they didn't give everything an answer, but they gave something like this.
Yeah, maybe that time you are not good in this concept.
No, definitely.
Now it is fine.
Yeah, fine.
Yeah, it is simple thing now. The only thing is properly interpreting everything. By seeing the equation itself, you can interpret this is 2a, this is k, this is omega. Over after that. Once you interpret the value of k, omega, a, then it becomes child play. Am I right? Third thing, wavelength, we can easily find. 2 pi to pi cancel lambda is equal to 3. Yes, obviously right. And frequency is omega by 2 pi gets cancelled, 60 hertz. Over. Third is speed, omega by k. Divide both, get the answer. Over. Question. What is there in this question? Simple question it is. But comes in 5 mark category, 5 mark or 3 mark category this question comes. Does not deserve to come in 5 mark, but comes because of psychological fear of the question. I am very sure most of you by seeing the question itself will give up. It will be tough, you will think. You will imagine that it will be tough question only. Because 0.06 sin 2 pi by 3 k x cos 120 pi t and all, what is this, sir? And if this in bracket x comma t, this things itself is actually making you afraid. I know about children. First, read the question, understand the question, and attempt it before giving up and losing the war psychologically. Can I proceed further? I should. If you want to see later, you can see in the video. Yeah. Now I am going to something which is called as standing waves on a string. As I said to you that the best example of standing wave is a guitar. Have you seen a guitar? At least you have seen in the videos and all. You would have even touched it and used it. If you have a guitar, you will see that guitar is having some 5-6 strings, isn't it? And each string is having different thickness. Have you felt it? Now you can imagine that why the difference in the thickness, because every thickness will decide the rigidity. More thick will be more rigid, thin will be free. So how the waves will be produced on the string is also governed by how much thick or how much thin it is. Another thing you would have seen in the guitar, if guitar is there, in the bottom it will be tied near that hole. At top there will be some 6 clamps. In that they will tie it. Okay, we are giving 2 ends to it. And you would have seen in the guitar there are some white dots. Seen it? Not mind that much. Not I just saw something there. If you see in a show or somewhere in the movie, hero or the presenter is having a guitar in the hand and playing the guitar like this and showing that I am playing guitar, don't believe that. Because if really you want to play a guitar, it is not only hammering that strings, it is also about the movement of this left hand. You have to press some strings. If you don't press properly, cheating. Nobody is playing, he is putting scene like, yeah, I am playing guitar. But really if you want to play guitar, your left hand should also move along with the strings. You know why? By pressing the strings, you are creating nodes. Why? I will come to that. Now this topic is very interesting if you are minding. Okay. So now what I am doing, I am taking some, for understanding the guitar case, I am taking a string and tying in both the ends. Okay. Its length is L. First, it is called as first harmonic or fundamental harmonic. If I move the string like this, like pluck it, the string in the center, what will happen? It will happen like that. It will move up and down. So when you are fixing in this both ends, definitely the wire cannot move up and down here. It becomes node. And if you are giving displacement here, this will become antinode. See, I will do that also. So yeah, can you feel what I am doing? I am plucking in the middle. What will happen? The string starts undergoing standing wave. But how many wavelengths are there? See properly. How many waves is there? One wave is there. Half wave, 2 waves are there. Very good, man. Sleeping or I don't know what. This is one wave, Mr. Avinash. Right? Now tell me how many waves is there in this? Half a wave is there. Be very careful. See, I am going to teach the most important part of today's lecture. For today's class, we have reached the most interesting, most important part. Again, 5-mark question comes from here and simple question, scoring question comes from here. If you are clear in this, this derivation will become child's play. Once again. So if I am striking the string in the middle, I am producing one wave. So that's why they have written that we know that minimum distance between the 2 nodes is lambda by 2. Anyhow, it is going to lambda by 2 here. So are you feeling how the wave is oscillating? That is, the string is oscillating up, down. We have made what wave? Stationary wave. Why I am saying stationary wave? Because stationary wave is the only wave where a particular particle will have only a particular displacement, isn't it? If it would have been a travelling wave or a progressive wave, it would have moved like this. All the points will undergo maximum amplitude, minimum amplitude, mean position. But here what is happening? Central point, maximum amplitude. As you go towards the end, the amplitude is reducing and the last point is node, 0 amplitude, right? I hope you are understanding this. So now let us try to find its fundamental mode, or it is also called as first harmonic. How will you find? It's very, very simple. See the derivation how it is. The length of the string is how much? L. And what is the wavelength? I mean the length can also be done in terms of lambda as lambda by 2. Can I write that like this? So what is L for the first harmonic? For the first harmonic, L is how much? Lambda by 2. Everybody agrees to this? Any doubt in that? Okay. So from here what we will get? Lambda is equal to 2L. Now what is frequency? Velocity. Always remember that velocity is equal to frequency into lambda, right? Yes or no? So here what will be the frequency? Frequency of the first harmonic will become equal to V by lambda. So, V by 2L, right. This V by 2L is called as the first harmonic, also called as fundamental mode. Remember that. V is the velocity of the wave and L is the length of the string. So, V by 2L is what? First harmonic. Copy it fast, nothing is there, only 2 lines. Copy it. For a string, this is called as first harmonic or fundamental mode. Fundamental mode of a string is how much? V by 2L, where V is the velocity, L is the length of the string. Remember this. If you allow me, I will go to the next page fast.
Just a second.
Others copied? Yeah. Root of? That is for longitudinal wave you are seeing the equation. This is a transverse wave, it will become root over T by M. I have not taught that, that's why I have not used it now. But V is equal to root of tension by mass. That will be there. I am not using it now because I have not taught. I will teach that in the next class, then I will add it if required. But now you can remember it is V by 2L. Okay.
Yes, it answered.
Done? So, I am going to the next page. Next comes the second harmonic. Second harmonic is also called as first overtone. Now, what is the meaning of that? Meaning is, I will intentionally create a node here. How I can create a node? I told you, by finger create node. If I press here, then this point will not be allowed to move up and down. And then I pluck somewhere here. Then how the wave will form, you see? The wave will form like this, isn't it? What I am doing now, I am making this point as node. Which point? This point. And then if I am plucking like this, it will produce the wave like this. Now see and carefully tell me that here this is 1 lambda by 2 and again a lambda by 2. So here how many lambdas are there? 1 lambda is there. So can I say in this case L is equal to lambda? In the previous case only lambda by 2 was there. Now length became 1 lambda by 2, 1 lambda by 2. So it became lambda. If L became lambda, what will happen to frequency of second? Frequency is what by what? V by lambda. So V by lambda and V by lambda will become equal to V by L. Second harmonic I got as V by L. What was the first harmonic? V by 2L. So can I say that second harmonic is 2 times the first harmonic, frequency of first harmonic? Can I say like that? Because if you multiply the previous one with 2, you will get the same thing. Are you getting what I have written here? Anybody has doubt in this? The first harmonic frequency was V by 2L. If you take V by 2L multiply 2, it will become V by L only, no? So I can write the second harmonic also as 2 times the first harmonic. Is it clear? If anybody has doubt, please ask me. Simple. Now what I am going to do? I am going to create 2 nodes inside. For third harmonic, what I will do? I will create 2 nodes. Then let us check how many this will come. Now itself, without going to the next page, we can tell you. Let us check now. If you have 1 node here, 1 node here, then it will create like this. Do you agree? Isn't it? So it will be lambda by 2, once again lambda by 2, once again lambda by 2. So how much it is? 3 lambda by 2. Length will become equal to 3 lambda by 2 for third harmonic. For fourth harmonic, lambda by 2 plus lambda by 2 plus lambda by 2 plus lambda by 2 will become 2 lambda. Fifth harmonic, 5 lambda by 2. Are you getting? Sixth harmonic, 3 lambda. How it is proceeding, you are realizing? As we are moving, making more and more nodes, the harmonic is also increasing and L and lambda relation is changing. So shall I go to the next harmonic, second and third harmonic? Have you copied this second harmonic? It is also called as first overtone. Now I am going to third harmonic. Third harmonic, as I told in that case, like this. There are 2 nodes here. If there are 2 nodes and there are 3 antinodes, actually totally how many nodes are there? You see, 1, 2, 3, 4, 4 nodes. How many antinodes? 1, 2, 3. So always antinode is 1 less than the node in the case of strings. That also you should keep in mind. In NEET exam, this question comes like this. Okay. Third harmonic you will speak. So third harmonic, what is the value of L? L becomes equal to lambda by 2, lambda by 2, lambda by 3, lambda by 2. So lambda will become equal to 2L by 3. Do you agree? And what we have the equation of frequency V by lambda. Lambda is how much? 2L by 3. So can I say that nu 3 is equal to 3 times of nu 1? Are you getting? We got the value of nu 1 as V by 2L. We got the equation of nu 2 as V by L, and then we got the equation of V3 as nu 3 as 3 into V by 2L. This I can also write as 2 into V by 2L. So can you feel that the equation, the nth harmonic will be how much? N times V by 2L. Do you agree with me? This is the frequency of nth harmonic in the case of string. What is the formula? N times V by 2L. One more thing I want to specify here. You are going to get all the harmonics. Nu 1, if I write nu 1 is 2, nu 2 is 2, nu 3, you are going to get 1 is to 2 is to 3. Do you agree? It may become 1 is to 2 is to 3 is to 4 is to 5, and it will keep on moving. Do you agree? Do you agree or not? So we can hear all the harmonics in a guitar. Understanding that? Already I have threatened him, you are also threatening him. Power. Yes, guys? I hope you are understanding. Anybody is asking something there online?
Yes, sir.
Tell me, brother, please.
Sir, can we relate this to the coefficient of linear expansion, superficial expansion, volumetry expansion?
In what way you are saying?
Sir, because those ratios also relate to the 1 is to 2 is to 3.
No. Alpha, beta, gamma is something else. Alpha by 1 is equal to beta by 2 is equal to gamma by 3. That is completely different from this as of now.
Okay, sir.
Okay? But one thing we are understanding from here, we are understanding that in the case of string, if both ends are fixed, we are going to hear all the harmonics. You know what is harmonic? Music. That's why the name came harmonium. Nobody is using nowadays. But harmonium is there, no? Still, if you see some great artists, they will be using harmonium. See some A.R. Rahman concert, he will still use harmonium. Harmonium is, name says harmonium. It has all the harmonics. You can hear very beautiful music from there. Anyhow, so I hope you are clear in this. All the harmonics of a string. Is it clear? I'll take 10 more minutes. Shall I? Yeah, you should not say no. Can I proceed, guys? Can I proceed? Online people?
Yes, sir.
Yes, now we are going to enter into a very good part of this chapter, last part of this chapter, where I have shown you some random person. I don't know who is he. Don't ask me, sir, who is he? Somebody I have taken photo from Google. They should not put copyright also. Okay. So that person, what is he doing? He is doing flute. What is doing flute? When he is not making, playing flute, right? He is playing
Yes.
flute. Okay, now tell me, how many types of flute you have seen? 100 types, sir. How many types? One type only you have seen. Why? Not seen this type of flute. Generally, this flute only we will have in home. Who is playing this kind of flute in home and all? We go and buy from market, they will give this kind of flute, we will play like this. If we do playing only, not real playing, that playing. So we will take and we will just press some holes in that and we will put some woo, like whistle, we will do it. We will not be able to make some music out of it. But I hope you are understanding. One second. Yes. Is it clear what I am trying to tell? So when we take a flute and when we play the flute, we have two kinds of flute. One is this kind, this gentleman is playing. One is this some foreigner is playing. Flute, 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 flute. Also God is also playing flute. So if you see, you will realize that almost all the flutes that they are playing is of this type only and not this type which we are getting at home to play, isn't it? So can we say that this flute is more superior than that flute, more professional? Okay, why? Why? Do you have any? Okay, but this also has notes. What do you think? This will not have holes. It will also have. Not given, but it is there. But you have seen, notice there. Definitely holes are there in this also. Holes will be there in both. But why are all the professional artists? He may also be some professional only, but some local, or he is one among 100 people sitting there. But they are some looking like some. By seeing itself, you can say some artist only, isn't it? So he also looking like, yeah, playing something very good. By seeing itself, by his face and all, hair and all, you can say, okay, yeah, good, experienced professional flute artist. So this flute artist. Now we are going to learn last topic of this chapter, where we not last topic of this chapter, last topic of today. That topic is organ pipe. So organ pipe is the musical instrument where you have a particular pipe kind of setup where you have openings. It may be both ends open or one end open, one end closed. One is called as open organ pipe. This is open organ pipe. Why open organ pipe? Because this end and this end, both ends are open ends. But this is called as what organ pipe? Closed organ pipe, because you are by your mouth you are closing one end. You may say that also open only behind, but by mouth you are closing one end. No? This pipe is called as closed organ pipe. So closed organ pipe will be closed at one end, and open organ pipe will be open at both the ends, there and there. Is it clear to you? Now today we will understand why open organ pipe are a bit superior than closed. It is true, it is superior only, I accept. Why it is superior? We will try to understand that. Okay. So now we are going to learn about stationary wave in air column. That is our open organ pipe and closed organ pipe. I will not take much time, so I am going a little fast now. I am actually going to the derivation. So now first we will talk about open organ pipe. Something like this it is. Both ends open, and see, both ends are open and you are playing flute from one particular hole, isn't it? Wherever you put your mouth and play, that will become closed. And you will have some fingers moving, right? 1, 2, 3 fingers, holes will catch by your fingers. What you are doing? You are creating nodes. Are you getting my point? Why the holes are given? Holes are given to create nodes. More nodes you create, more harmonics you are creating. Let us try to understand this. How? So if you see the first case where I am having what? The first fundamental harmonic, and let me talk about this. Yes. So here how many waves are there? Can you feel? The wave is like this. This is a node. I will draw it actually. This is the organ pipe, right? And here they have made a node. So it is going like this. Something like this it is going. So this is 1/4 of a wave, I think, right? And again 1/4 of the wave. So L/4 and L/4 will become L/2. So can I say here L is equal to lambda/2? That is how they have given also here. L is equal to lambda/2. How lambda/2 came your understanding? Because this is 1/4. Again this is 1/4. So lambda/4, lambda/4 became lambda/2. Was she understanding or not? This is one complete wave. See properly, you will realize this much only they are taking here. 1/4 only they are taking of the wavelength. So L/2 is the length. So what will be the lambda value? 2L. If lambda is 2L, what will be nu 1 or first harmonic? That will become equal to V/2L. Clear? Simple? Copy fast. I will go to the next page then. Copy fast, copy fast. We will end in 5 minutes. Last 5 minutes. What, man? Let us go. It is similar to the strings. Yes, it is similar. Only the open organ pipe. Closed is not similar. Closed is different. So draw the organ pipe, length lambda/2, and just write that basic thing. Length will become equal to lambda/2, lambda will become equal to 2L, and the first harmonic will become equal to V/2L, right? This is called as first harmonic, also called as fundamental mode. Remember these words, overtones, modes, be very clear in that. Can I go to the next page, if you allow me? Shall I? Okay, thank you. Now I am going to second harmonic, also called as first overtone. What I am going to do, I am going to create two nodes here now. By my fingers I can create nodes. If I create two nodes, how many frequencies, how many lambdas there? See, lambda by 4 plus lambda by 4 plus lambda by 4 plus lambda by 4. 4 times lambda by 4, how much it is that? Lambda, isn't it? So when you do that calculation, you will get L is equal to lambda here. So if L is equal to lambda, then once again same like the previous thing, nu 2 will become equal to what? V by L, or I can write nu 2 as how much? 2 into V by 2L. That is nu 2 is 2 times of nu 1. I hope you are agreeing with this. Very similar to strings. Very similar to strings. Closed organ pipe is having lot of similarity with string. Sorry, open organ pipe. Closed organ pipe is only a little different from this. Let me know when you are done copying. I will move ahead. Make it fast. The more sooner you write, the more sooner I can finish. Today I came in with my mindset I will finish organ pipe, so I am finishing. Okay, shall I proceed? Shall I? If you are missing something, don't worry, you can copy later also. Yes. Next comes, so nth harmonic they are doing. Directly they went to nth harmonic. So first we did, second we did, so nth harmonic will be how much? You should tell me. Nu n will become equal to n times of V by 2L, isn't it? Or nu n as she told, n times of nu 1, right? So once again here also if you write nu 1 is to nu 2 is to nu 3 is to nu 4, it will be 1 is to 2 is to 3 is to 4 is to, like that it will keep on going, isn't it? So open organ pipe is capable of producing all harmonics. First harmonic, second harmonic, third harmonic, fourth harmonic, fifth harmonic and all the harmonics. Can I go to the next page? It is very similar to strings, you can copy from there also. Varsika is struggling today to copy. Don't worry here, you will copy later. Okay, shall I proceed further? Allow me please. Next comes one end closed. That guy was playing, no, that foreigner guy, white color kurta he was wearing. So now what we are doing, one end we are closing. The moment you close one end, you are forming what? A node here, right? So how the diagram will be? One node, one antinode. So let us draw it for you. This is the closed organ pipe, right? One node here, antinode here. If I join like this, 1/4 of the wave is coming. See, you should be very clear in understanding how many wavelengths are coming. That is very important. Why it became lambda by 4, I am making you understand that. In exam you will forget it. So understand how it is coming. It is coming purely based upon this wave only. So from here to here one wave, this will be 1/4 of the wave, isn't it? So what I am getting here, only 1/4 we are getting. So length is lambda by 4. So what will be lambda? 4L. So what will be nu 1? V by 2L, man. V by 4L, right? V by 4L is the first harmonic. So fundamental mode is different from the last two cases. Fundamental mode for a closed organ pipe is how much? V by 4L. Here I am talking about closed organ pipe. Open organ pipe 2L. Clear? Can I go to the next page? I hope you are writing properly. Next what I will do, I will create a node. How I will create a node? See, you may think why third harmonic? By mistakenly he wrote. I will tell you why I wrote third harmonic. No, I am not writing by mistakenly. So here I am going to create a node here. Now see how many lambdas are coming. See here, lambda by 4, lambda by 4, lambda by 4. Am I right? So here you can say L is equal to 3 times lambda by 4. So what will be lambda? 4 into L by 3. So what will be nu 2? Yes, it will become V divided by lambda. Lambda is what? 4L by 3. What you got? Third harmonic directly you got. So actually you not got second harmonic. What you got? Because here you are getting nu 3 as 3 times of V by 4L, which is first harmonic. So nu 3 is becoming equal to 3 times of nu 1. Do you agree with me? Same way, if I go to fifth harmonic, second overtone, how it will be? You tell me. You tell me. In the same organ pipe, I am going to make 2 notes now. One node here, one node here. So from here, like this, it will come. Once again, like this, it will come, and like this, it will come. Lambda by 4, lambda by 4, lambda by 4, lambda by 4, lambda by 4. 5 times of lambda by 4 will be length. So lambda will become equal to 4 times of L by 5, isn't it? 4L by 5 will be lambda. Put that there. You will get nu 5 is equal to 5 into V by 4L, right? What we are coming to know? In the case of closed organ pipe, nu 1 is to nu 2 is to nu 3 is 1 is to 3 is to 5 is to 7 is to 9. Only odd harmonics are audible to you. That is the reason in closed organ pipe, people are not able to hear the even harmonics. That's why professional people are using open organ pipe, because open organ pipe is capable of producing all kinds of harmonic, but closed organ pipes are producing only odd harmonics. It's a very interesting concept. I went fast, but I had to, because I have to leave Shweta for studying biology. Can I proceed further? Can I close the session? Sorry. Can I close the session? If you have understood today's class, then today I was able to tell you what is string, what is organ pipes, how it works, stationary wave formation, something very important I taught today. Something very important I taught today. Next class we will be learning about beats, and we will be learning about velocity of longitudinal and velocity of transverse wave. This chapter will be done by that time. So next class I will be focusing on solving some more numericals, and we will be going to the remaining part. Till then, take care. Bye bye. Good night. We will meet again in the next class. You can drop. Bye bye.
Thank you, sir.
Take care.
Bye.
Thank you, sir.